Hi, I'm Dr. Twaseem and welcome to my Derm Classes. Today's lecture is on Measures of Association, which is lecture 2 on the Epidemiology series. I've been trained from Harvard Medical School on research methodology, so I hope I'll be able to share some insights with you. So let's get started. First, a recap of what we have learned in the previous lecture. So we've learned about the outcome and how to measure an outcome, which is basically determines the distribution of the outcome in a group of subjects. For example, if it's lung cancer among smokers, that is an outcome measure. And there are different types of outcomes. So if it is binary, then we go for proportion, we go for odds, and then we also have mean if it's a continuous outcome like that of an age or height. Binary stands for basically presence of hypertension, absence of hypertension, and then we also have the incidence and prevalence, which is again measures of a binary outcome. So we are going to learn today about the measure of association. So this basically determines the extent to which the measured outcome occurs compared to normal in a group of subjects. For example, how much lung cancer occurs among smokers compared to non-smokers. So that basically determines the measure of association. So we'll need a comparison group, and another thing is that we also need to rule out the alternative explanations, which is basically chance, bias, and confounding. So chance is because some occurrence has happened and can be simply because of chance. For example, you toss a coin and you got 10 times head. It can be because there is any problem with the head or the tail or the structure of the coin, or it can be because of pure chance. And another thing is the bias. The bias actually influences the way in which you pick the subjects for your study. Probably there is a problem with that, or it can be because of confounding. These are the factors that can determine the outcome, but they are unequally distributed in the two groups, so they have an influence on the outcome, due to which that you found that there is an association. So you also always need to rule out the chance for chance, bias, as well as confounding. So what are the different measures of association? So this basically determines the association between the exposure and the outcome. It can be any interventions and the outcome. It can be any risk factors or the outcome. And what are the measures of association? So these are basically odds ratio, risk ratio, rate ratio, which are the proportional or the relative measures, or it can be the absolute measures like risk difference, mean difference, or it can be regression coefficient. But what you need to know is that not all association need to be a causation. For example, there can be mere associations that occur. So you need to put in your logic and think whether this is actually a reason for the outcome occurrence. So that is what's meant by not all associations is equal to causation. Coming to the ideal study. So in an ideal study, for example, if you're observing occurrence of lung cancer among smokers, what you need to do is that you need to take back in time these people and then see what would have happened if they didn't smoke. So that is the outcome too. And in an ideal scenario, you're actually trying to observe the difference between these two outcomes in two different scenarios, and then that actually determines the causal effect of the exposure. But as we all know, it's actually not possible to do this. So that is the main problem in an epidemiological study. So the only way you can do this is if you have a time machine, and if you could go back and under the same circumstance, the same individuals and the same scenario, what would have happened if there was no exposure. So next, coming to what is the role of epidemiology. So in epidemiology, what we are trying to do is we are actually trying to find a comparison group which will actually act as a proxy for this particular scenario. So we have the factual outcome where you have the exposure and then you have got the outcome, and then we also have got the counterfactual outcome where as I have already mentioned, a scenario where what would be the outcome if the person was not exposed. So we need a comparison group that actually would match as a proxy for the other scenario, and this actually determines the measure of association. So we need an ideal comparison group in order to do a very good comparative study. So this is where the problem with the bias and confounding can come if you don't pick your comparison group properly. So coming to the types of measures of association, we have two main different types. So one is the relative comparison, which actually measures the ratios, and then we have the absolute measure, which actually measures the difference. So the ratio actually indicates the relative increase or decrease. For example, two-fold increase, there is a three-fold increase. So that actually assesses a causal association. And then we have the difference measure, which actually measures the absolute difference. So we can say there was an absolute increase or absolute decrease. For example, if you got the occurrence of lung cancer among smokers as 100, and if you got the lung cancer occurrence among non-smokers as 50, a ratio measure would be 100 by 50, and we say there is 2 times the occurrence of lung cancer among smokers, and the absolute difference would be, we say there was 50 increase of lung cancer cases there was an absolute difference of 50 between these two groups. There's an absolute increase, there was an absolute increase of 50 cases. So that's generally done for public health or clinical impact, but actually you're trying to see for example, the absolute difference of a vaccination protocol that you have implemented, something like that. And that's basically used for the public health or public in order to assess how much clinical impact it has got on a population level. And then we have the proportional measure of association, which I will deal in detail later. So I'm just giving you an example here. So we have got a cohort study, imagine. So we have got an exposure plus and minus, and we also have got occurrence of disease plus and minus. So I'm just going to give you equations of how can you assess the risk. So an outcome measure would be the risk of disease in the exposed. So that is determined by, as you can see, A by plus B. So this is very important. If you want, you can take a screenshot or write it down somewhere. And then we have a risk in the unexposed. So we take C by C plus D. As you can see, it's occurrence of disease among unexposed. So this actually measures the outcome in two different groups. So risk is basically an outcome measure. And then we actually wanted to know if there is an association between these two. That's a measure of association. So then you're going to find about the risk ratio. In that case, we will do R1 by R2. So that is a relative measure of association. And then you have risk difference, which is R1 minus R2, which is an absolute measure of risk difference. And then we have odds ratio. So generally in a cohort study, we can calculate the risk ratio, but we can also go back and calculate the odds ratio. The odds ratio is mainly calculated for the case control studies. So you have AD by BC, which is the formula for the odds ratio. So it's odds among exposed to odds among unexposed. So that comes to AD by BC. Another formula that relates to the risk is R1 by 1 minus R1. So that divided by R2 by 1 minus R2 gives the odds ratio. So I'm just giving an example of this. So for this moment, what you can do is you can just pause for a moment, take a screenshot and try to write down all the formulas and put these numbers into it and try to calculate the odds ratio, the risk difference, the risk in each individual groups. So pause for a moment, and once you're done, you will get the answers as this. So risk ratio you'll get as 1.3. So smokers have it. You can interpret it as the smokers have 1.3 times the risk of. In this case, I've just considered occurrence of hidradenitis suppurativa among smokers, so it's just compared to non-smokers. And then you might get a risk difference of 0.1. So you can say the smokers have an absolute risk of 0.1, or you can say 10 cases per 100 compared to non-smokers. And then you can go for the odds ratio. Again, you would get that as 1.3. So you can say smokers have 1.3 times 3 odds of getting hidradenitis suppurativa. So what you need to note here is, in a very small risk ratio, it would be equal to odds ratio, but this won't be the case in case of bigger risk. That's something that you need to keep in mind. So now we'll go on to discuss a little bit on odds. So now we'll discuss about the odds ratio. So odds ratio basically is a type of measure of association primarily used in case control studies, but it can also be used in cohort studies, and it can also be obtained through a statistical method called as logistic regression, which actually helps to control for other factors that can contribute to the outcome. So we'll learn about that later. And then there is a symmetrical property where odds for not developing the disease is 1 by odds for developing the disease. So that is what's called a symmetrical property. And then we have the disease odds ratio will be equal to the exposure odds ratio. So we'll just depict that in the following slides. So this is what I mentioned about the symmetrical property. So here the odds for not developing the disease is 1 by the odds for developing the disease. So as you know in the previous example, if you could go back and calculate the odds ratio, that was 1.3 for developing the disease. So if you could calculate the odds ratio for not developing the disease from the same table, what you would get is 0.75, which is 1 by 1.3. So next is disease odds ratio is equal to exposure odds ratio. So what I want to do is go back to that table. So what we have found out is a disease odds ratio from that table as 1.3. I want you to do the exposure odds ratio. So when you do the equation, what you can find is it comes as AD by BC again in a different way but the same number. So that comes again as 1.3. And as I mentioned before, the odds ratio will be equal to risk ratio in a very small risk. Now let's do the rate data. So this is one of the most common data that has been assessed in a number of studies, especially in cohort studies. So why we need to do the rate data? So the rate data basically determines the incident rate that takes into account the fact that there might be loss to follow-up and there might be death of the patient. So here what we are taking into consideration is the person time that's contributed by the people. For example, if one person has contributed 5 years and the other person has contributed 10 years, the total person time comes up 15 years. So the denominator is a person time. So in this case, what happens is incidence rate in the exposed would be, as from this column, it would be A by N1, which is the person time of the exposed individuals. Understand? All the people who are smokers, for example, how much have they contributed to the study? So that is the person time. And then you have the incidence rate among unexposed. That would be again C by N0, which is a person time of the unexposed people or the non-smokers in the study. So this is the rate data. And so what is it called if you have a rate data? So you have two rates from two outcomes. Once you do a relative equation, it comes as rate ratio. So that is R1 by R0. And if you want an absolute difference, so that becomes a rate difference. So what happens is that, for example, if you get the answer as 1.86, you can say the smokers has 1.86 times the rate of hidradenitis suppurativa compared to those non-exposed. So this is rate ratio. So the question is then what do you mean by relative risk? For example, if I say the relative risk of lung cancer among smokers is higher, does that indicate an odds ratio? Does that indicate a rate ratio? Does that indicate a risk ratio? So if you can think about it, all these are basically relative risks, right? So these three are called as relative risk. So if somewhere you have an interpretation of relative risk, you need to go back and see which one ideally are they saying about. And as I mentioned, the risk is same. If it is the odds and risk will be the same, and apart from that the risk ratio, rate ratio, odds ratio would be the same if the risk is small. So this I don't want to elaborate on this because it's basically a derivation that you need to do, but at the end of the day, if it's small, it's generally the same. Or if there is no association, for example, if it's 0, then it's 0 for the three odds ratio, risk ratio, and rate ratio. In that case also it is the same. Coming to the proportional measure of association. So what is proportional measure of association? So this is basically a scenario where you are basically reflecting the amount of the outcome that could be caused due to the smokers. For example, you have 100 lung cancer cases. How many of these would be due to smoking is proportional measure of association. So the main two types of proportional measure of association is attributable fraction and total attributable fraction. So it's basically determines the differences. The main difference is that in one it's among a group of subjects and in the other it's among the population. For example, you say there is 100 cases of lung cancer, in that how much can be attributed to the smokers, and then we have the risk among the for example the population. In particular population you have this much cancers, so how much can the incidence can be attributed to the risk. So this is the main formula for the measure of association. So I just want you to pause for a moment, take a picture or write these down, the formula that can be used in order to assess the attributable fraction or the total attributable fraction, which is among the population. So the next concept that you need to know is the number needed to treat or number needed to harm. So what do you mean by number needed to harm or number needed to treat? For example, you take number needed to treat. It is how many number of individuals you need to treat before you can see a positive outcome. And the same goes for the number needed to harm. It basically stands for the number of people who have to be given that particular exposure. For example, if you are taking smoking and lung cancer, how many of people need to be exposed before one can develop lung cancer? That is number needed to harm. So the formula is basically it is 1 by the risk difference. So in case of harm, a negative term might come in, number might come in, due to which you use this absolute thing. So then it is 1 by the risk difference. So this is the formula for the number needed. So next is about the regression coefficient being the measure of association. So how do you determine the regression coefficient? So this is basically the regression analysis is basically a statistical method. So it can be linear regression, and then we have the logistic regression. So linear regression is where your outcome is a continuous measure. For example, height of an individual is a y, and then you have beta 0 plus beta 1 into x. So where the beta 1 would be the regression coefficient, b0 would be the intercept, and then you have the x. For example, if height of an individual is your outcome, you can take x as the height of his father, and beta 1 would be the regression coefficient. And then the next is you have, so this is what I've mentioned already, and then you have got the logistic regression. So the difference between linear and logistic regression is that the outcome in a logistic regression would be binary. For example, presence or absence of hypertension or presence or absence of lung cancer. And in this case, the beta 1 would be odds ratio. So you have a formula where you derive all this, which is not very important. So what you need to know that in a logistic regression, the beta 1 would be the odds ratio. So now what I'm going to do is I'm going to take you through some exercises where you can read whatever we have learned as the measure of association in some of the studies. So as a part of this lecture, I've taken some dermatology research articles. So let's start. So as you can see, this is basically a study on increased risk of cutaneous and systemic infections in atopic dermatitis patients, which is actually a cohort study. So this is one of the articles that's been published in Journal of Investigative Dermatology. I'm just going to take you through the results that I have mentioned here, so that whatever you learned is getting applied. So as you can see, the highlighted things, using multi-level mixed effect logistic regression. So the method that I have used here is logistic regression. They found that there is a 55% increased odds of impetigo to a 3-fold increased odds of molluscum contagious. So from the logistic regression, they have derived the odds ratio, and they have found that there is this many increased relative risk in the people with atopic dermatitis. I hope this is clear. And then let's go for the next article. Here what they have done is a nationwide population-based cohort study of incidence of severe and rare infections among adults with psoriasis in Denmark. So they've tried to again understand the infections in psoriasis patients. So I'm actually going to take you through the results here. So what you can see here is that they've written IR, which is basically the incidence rate. As you've already learned, incidence rate actually takes into account the percent time as the denominator. So incidence rate is 3104.9. But they haven't actually mentioned the percent time. So that would be a doubt that you might be having in this case. So we are actually going on to the next slide where you can see if they have actually determined it based on the percent time. So as I went on into the article and just looked at the table, what you can see is that incidence rate per 1 lakh person years, which is actually not given in the results. So the incidence rate, it would be person time. So you will need person years being set as a in the results or in the description.